All right, guys, let's pay attention. Now, this program carries on to your space battle simulation. It goes into a little bit more details. I introduce certain things such as the abstract class, which is like an interface, except interface prescribes that you must implement methods which are presented in the interface. An abstract class is a class which cannot be instantiated, but you can inherit from an abstract class and you can get commonalities of behaviors. So let's say I wanted all the programmers on my team to implement the do battle method in exactly the same way. I would write the abstract class with that method and I'd say to inherit from it, and it would be a way of achieving enforcement of consistency across what different teams are doing. So anyway, let's run this and take a look. So we're going to use our favorite new tool of the debugger. Right, so I'm going to go here and go to my main method, and I'm going to drop a debug point right there. You know what to do. I showed this on Friday. And I'm going to go here now and run via the, oh, actually, I'm in my debugger from before. So be careful with that because I do that all the time, right? In class, I illustrate something. I stop to make a point. I come back, then it acts all messed up. I realize I'm still in my previous debug session. So let's say stop our debugger. And now I'm going to click here on this little insect thing, which is how you get in a debugger. And I'm going to introduce a couple of new code archaeology tools as well here. So let's start by dropping watches in some of these variables. And I still owe you a video on the von Neumann architecture. Get to that tomorrow. So we're going to make sure our debug point is active, and we're going to run via clicking on this little debug icon right there, and we're going to drop some watches. Right, so I'll clear out whatever I had before. And it's unresolved because we haven't stepped over that line yet. So I could have an option here. I could step into, in which case it would bring me into the source code of Kotlin because it's open source. And that's an amazing exercise, by the way. If you seriously think you're going to talk some employer into paying you money to do this stuff at work, I would suggest spending many hours going through the source code with the debugger. But for right now, I'll skip over because I just want to create my vacations mutable list. And now here, vacations has been created. Right, it's an array list. There's nothing there yet. Size 0. So now we're going to add, because vacations is a collection object. All collection objects in Kotlin implement the same interfaces, so they all have an add method. And what are we going to add? Well, we're going to go to the vacation object, and I showed you in the video the other day how to turn on your outline tool. I love the outline tool. It's cool. So tool windows outline, or structure rather, structure they call it now. And that gives you this right here. So you can get an overview of all of your classes and all of your methods in each class. You can double click to jump to anything. So if I go to my vacation, yeah, see there's the constructor right there. Data classes, by the way, now, we've talked about them. They're just classes which model data, right? They just tell you which data fields are available in an object. They're objects without methods. That's all they are. So nothing big deal there. Let's go back to vacation. There's my companion object we talked about on Friday. There's my create vacation. So that's my thing. That's my factory method for vacation. Now, it makes sense that this has to be a static because I need to run it when I have not yet made a vacation object, so it has to be available at the class level, so there it is. And once I call that, see, there's my signature. I'm going to make a type of vacation, scuba diving, fishing, or hiking, and I'm going to give it a price or a cost to the user. Oops. So let's continue. So now I'm going to add some vacations to my vacation collection. So I'm jumping into my constructor right there. There it is. Now I'm into the string class of Kotlin. I don't want to step through this, right? I'm not debugging anything here. So remember we said there's a way to step out. If you're in a method and you just don't want to be there, just click on the step out option. It'll bring you back to the point of calling. And now I'm just going to call this code right here. And it's just going to return when I get some type assigned, which is going to happen on one of these lines. And if for some reason, and I can't really see in this code how that might happen, but if I try to, maybe if I was trying to create a type and then my type code, my type creation code had an error and it didn't get created, I guess that could happen. I'll throw an exception. But for right now, I'm going to step over this. And now, if I go and look at vacations, so I have one kind of vacation there, which is a fishing tour, and there is the memory address, because in the heap memory, remember von Neumann, heap and stack, so there's your address of your heap memory. So you have a fishing tour vacation object in our collection. Okay, let's continue. So step to next. So now I'm going to step over these because it's going to be the same thing we did. I strongly suggest you do this exercise by yourself. So we'll step over adding a scuba vacation and adding an eco wilderness hike. And now we're back here. We're going to insert these vacations into our vacations collection. Now here we're making a random number. In the real world, if you're running a simulation, you would study your business records, or maybe like in some sort of a factory assembly line or something. These days, Internet of Things sensors are all over the place. You might hook it up so your production environment is directly feeding into a Mongo database, for example. You could go and query it there. But because we don't have actual real production records, we're just using random number generator to generate stuff like our price. Now, this is not a particularly realistic simulation. If it were, I would also have the cost, because it's fine to say that my income from a scuba vacation would be, whatever, $1,000, whatever. But unless I know my cost to deliver that, I can't know my net revenue. However, just to keep it simple, I sort of ignore that. All right, let's carry on. So there we're making a random number. We're seeding it with 32, with 42, whatever. That's just because if we wanted to have several random number generators in one program, we wouldn't want them all to spew out the same sequence of numbers. That is actually not really random. Computer programmers have religious fights with each other about what counts as being truly random. Suffice it to say, this is what's called pseudo-random, sort of kind of random, but not really. So anyway, good enough for us. So let's carry on to the next line. Now we're making another data collection, which is an iteration data list. Let's go and look at our iteration data object over there. And that is just outputting. That is just a container. That is just holding some data records of our various kinds of excursions with their price. And I guess if you want to really challenge yourself now, right, if you think you're one of my alpha performers and you're way up there, go and just add a random number generator to generate a delivery cost of each of these things, and then modify the algorithm so you're getting the net revenue after cost. And if you do that, then paste it up in the Slack channel so the rest of us can be proud of you for doing that. Let's carry on. So next. So now we're just going to iterate. We're going to generate 10 vacations. And there's your abstract class, right? So abstract vacation implements certain things such as a create vacation constructor and the companion object. I'm going to step over this stuff. So we're doing the same thing for 2 more vacations. Now we're calling our get vacation data method. So you can go and study over here in your structural outline what that means. Or you could also just search for it. Get vacation data. I'm just going to demonstrate this here now. Right there, actually, right there. So if you do that, then that can take you to the implementation, and that just brings us back to where we were before. So let's carry on in our debugger. So now I'm in my search mode. I need to go back to my debug mode because these things are called perspectives, by the way. The only thing an editor is, whether it's Eclipse, Android Studio, IntelliJ, or any of these other ones, Visual Studio Code, they're just basically 3 things. They're a runtime platform. They're a language server, for C++, Java, whatever you're in. They're a language server which gives you linting and a debugger, and they give you editors, intelligent, code-aware editors, which can do things like auto-completion and use color coding to call it out if you made a mistake. And the third thing is a perspective, and a perspective is nothing more than a combination of an editor with tools which are situationally appropriate for that thing you're doing. So I have to go back to my debug perspective. There it is. And I'm going to click to my next line now. Right, so I'm generating, I'm returning whatever's the vacation for that map entity. I'll step over that. And now I'm calculating my profit. I'll step into that so we can see it. So now I'm parsing my vacation data.sumOf. So I'm using the iterator we looked at with our collection objects. And I'm back here in my vacation class data. Vacation data class. And there my total profit is just whatever is my profit return from the class. Once again, if you want to look for a way to challenge yourself, jump in there and add some costs as well and modify, upgrade that calculation. So now we're just going to iterate over all of our vacations. I'll just step over this. You should go and do this by yourself. But I love the debugger. It's cool for 2 purposes: showing you the values of your variables at any point and showing you the flow of control. One of my profs in 4th year always used to go on this. He said, if you really want to learn a language well, write a debugger for that language. And I did that. That was my 4th year term project. I wrote a debugger for C programming language, and you really learn every aspect of it when you do that. So if anybody wants to do that, let me know. I'll get you started on it. You can actually use Kotlin to write a debugger for Kotlin because Kotlin's extensible. So now where are we right now? Yeah. So here we're going through our for loop. Where are we currently? Let's find out. Watch the counter variable. We're first time through. So now I'm going to show you another debugger trick. I don't want to iterate over all 10 times of this loop. So I'll drop another debug point right there after the loop. And here in my debugger control panel, I'll say resume. Resume brings you through to the very end of the program or to the next debug point. So I want to quickly shortcut myself over to line 90. I've dropped a debug there, so I'm going to say resume, and it dumps me down here. I can check my iteration list data again. Watches. Currently nothing in it, so we're going to add something now. So I'll say step over, because if I step in, I'm going to go to the Kotlin source code. Right, so we'll say step over. And now my iteration list data contains data for fishing tour, scuba. Now remember, the purpose of this simulation, we're going to run the simulation 10 times. Each time we're going to modify, using random numbers, some variables such as what is our cost and how many people engaged in the vacation at that cost. Now I've set the program to output a CSV file, and the analytics are going to be kind of meaningless in a sense, right? Because it would only be meaningful if we had a really correct, truthful correlation of the number of people taking it at a certain price. And we don't have that. It's going to be all over the place. But it's comma separated value. You could pull it into Excel and you could graph it. In fact, price discovery is one of the big things here now in the platform economy. We want to know the most amount of money we can charge our users for a certain service, and how much, because at a certain point we charge them more, and our revenue keeps going more. But at a certain point, people will say, "Well, screw you! I'm not paying that much. You bunch of thieves, go away." So they'll go away, and they'll do something else. So there's a thing in quantitative analysis which is called price point optimization, which is just before your ratio of diminishing returns. So it's how much you can squeeze your poor customers before they have a revolt and they just stop buying service from you. Price point optimization is a part of cost engineering. In fact, that's what Uber does, right? You know the Uber app because it has access to the details of your phone. So if it's 3 o'clock Wednesday afternoon, middle of the day, standing beside a subway station, right? You don't have anywhere to go. If you use Uber to get a ride from Yonge and Shepherd to, I don't know, your home, might be $15. But now, if it's like, 2 o'clock on Saturday morning, you just stagger drunk out of the club, and the subway is closed, and it's freezing rain, and your phone is down to 2% of power, they're going to charge you like $50 or $70 because they know you'll pay it because, well, if your phone's about to run out of power, you got to get home. So that's how they do price searching. In fact, I learned about this reading a very interesting book, which I commend to all of you, called The Platform Economy. The Platform Economy talks about how platform-based business models use big data methods and use quantitative optimization to do exactly things like determining from empirical data. They figured out how much they can charge the customer and keep getting enough customers. So go and read this book, please. It's going to be your future platform economy. Or is it called The Platform and the Pipeline? It's one of them. Platform and the pipe. Because the pipeline is the old business model where you make a bunch of furniture, right? You make tables and store them in a warehouse till people come and buy them. And this new model is now called the platform, like Uber, Airbnb, Amazon, where or music distribution, right? You can generate the product on a just-in-time basis, so you're not tying your cash up in standing inventory and so on. Is it platform and pipeline, or is it, what's it called? Platform economy. Just a second now. Kindle. Yeah, so I'm strongly suggesting you read this book if I can find it. Yeah, so read this platform revolution. That was it. And also read Machine Platform Crowd, which talks about how new businesses are being built with artificial intelligence and big data. And of course, the third one you need to read if you want to have a place at the table in the future economy is The Mathematical Corporation. All right, so go and read those books about AI and its intersection with big data and driving business value. Give you good things to talk about on the job interview. So let's finish this up now. Yeah, so we're iterating. We're making 10 iterations with some variances according to cost and randomly generated number of people who will purchase at that cost. In terms of your Earth Defense Force simulation, I didn't want to make it too complicated, but that would sort of be the next step. You could then calculate based on your allocation of power between phaser shields and your quantum, or no, I didn't give you quantum torpedoes. They're a bit complicated. I gave you photon torpedoes to work with. So you could identify, that would be a quantitative optimization problem, how to allocate those resources, because it's all about resource allocation, how to allocate those resources in a way that would conduce to getting the maximum survival rate. Okay, so here we are. So we've added that. Now we're just going to go and make a CSV file, which is going to contain this data. I'm going to say continue to the end because I think I've showed you all the cool stuff here. And now we've generated our comma separated value file. If you want to go and look at that, it's here. Right there. And then you could go and open that in Excel and, I don't know, play around graphic and all that stuff. Although these days it would make more sense. People aren't using Excel anymore for data analytics. They're using Claude API calls and telling the AI to graph it, but we'll get to that another day. A lot of those old systems are being reworked now to work with making AI as the central controller. So hopefully some of you guys are going to cut out some good jobs for yourself, right? You're going to cut yourself a piece of that pie and you're going to get out there and make a lot of money doing that stuff. And if you need more advice exactly how to do it, well, ask your questions and I'm happy to answer them. So there is our profit data, comma separated value file generated just now by the Kotlin program. And again, these aren't really meaningful data because it was all randomly generated. However, if I wanted, definitely drop and do some charting on that. So there's my total profit for each iteration, including all 3 vacation activities. And there was my profit for the eco hiking for each iteration. Sometimes it could be 0 because of random. And for scuba and for fishing tour. And here's number of customers we got for each thing. So just to finish this up, if you wanted to graph that, and play around with some Excel graphing. But making good Excel graphs is a skill I'm not going to spend time going into right now. All right, so that's about it. Any questions, let me know. Play with this. I'm going to try and kick out another couple of videos this week. Don't want you guys to be bored during your reading week break, right? So we'll try and get some more exciting stuff going. Stuff I don't really have room for in the course outline, so I can't talk about it in class. However, maybe we'll get some stuff with. Actually, why don't we try building a debugger tomorrow? Yeah, I think I think that'll be cool. We're going to try doing that. All right, good night, guys. See you later. Enjoy your time off. Bye-bye.